Hi, this is Mr. Ye. Today I would like to talk about the 12 basic functions. You have to remember 12 basic functions. You have to remember a few things. You have to remember every function. You have to know how to graph every function. So the number one thing is the most important thing. You have to know how to graph every single one. So we're gonna have a quiz on this. Graph on every single 12 graph on 12 basic functions. You have to remember it on top of your head. You have to know, by looking at the graph, you can analyze what is the domain and range. Domain and range. Okay. And by looking at third thing, you gotta be able to tell me if there's a bounded, below or above. Okay. Below or above. Also, you gotta be able to tell me if it's even or odd function. It's even or odd functions. And you gotta be able to tell me where is the x-intercept. X-intercept or y-intercept. Probably more likely it's gonna be the x-intercept. So every graph, you gotta be able to tell me all these things. First of all, you have to memorize all 12 graphs, and then you gotta be able to tell me, if you know how to graph it, then you should be able to tell me domain and range. And domain and range, you should be able to tell me bounded below, above. You should be able to find it from even or odd function on this, or by looking at the graph. So you can look at the graph on this one. You can look at the graph on all this, and you can tell me if they're even or odd functions. And you can tell me where is the x-intercept or y-intercept. Okay. In this case, the most of the graph have some type of intercept. Okay. Why is that intercept important? Because that usually able to tell you how do they shift, how the graph shift, and also known as a vertex on some of the graph. So it could be x-intercept, y-intercept, or vertex, which is the bounded point. So you gotta be able to know all those 12 graphs. And let's start looking at first one, and we're gonna erase this. So you're gonna copy down this. What are you looking for? Okay, 5 things. You have to memorize all the graph first, and second, you have to find a domain and range. Third, you have to find a bounded below, above. You can look at the graph and tell me that. And fourth, you gotta be able to tell me it's even or odd functions. Fifth, you gotta be able to tell me the x-intercept or y-intercept or the vertex. Okay. So now here, let's start with the first graph. The first graph says y equal to x. And what is y equal to x graph? Y equal to x. So y equal to x, and this graph has a domain of negative infinity to positive infinity, because you can look at the graph, x value can be any value. Range is also the same way, negative infinity to positive infinity. There is no bound, because the range could be anywhere, domain could be anywhere, so there's no bound. And you're gonna tell me this is odd functions. Again, we just kind of review what does odd function look like. Odd function, you're gonna have here to here. It's a mirror, and if they are mirror image to each other, the red line is a mirror, and if they are mirror image, then they are odd functions at the origin. So they say, okay, this one is an odd function. Also, you can prove it by using algebraically. algebraically says f of minus x equal to minus x equal to minus f of x, therefore is R functions. Okay, and the intercept is going to be at 0, 0, so is x and y intercept, x and y intercept, and that's equal to first graph. So this one you should already know from before, and now we just have to look in detail. Domain, range, bounded, are the even functions, x and y intercepts. In this case, x and y intercept both located at 0, 0. So that's the first graph, and let's go to the next graph. So let's go to y equal to x squared, and y equal to x squared is very important graph. You think about Angry Bird is making $300 million on this graph alone, and it's basically put this x squared upside down, which is negative x squared, and it's going to be reflecting against x-axis, and you say, okay, this graph is very valuable, it has a lot of money, and you look at this, you say, okay, how do I know the domain and range? You're looking at the graph. Domain, it can be all real number because it doesn't have any type of restriction, as you can see from the graph. And the range is going to be, this one has a restriction, and actually it's going to restriction going to be looking like this. You should be able to tell from the graph. And this is from 0 to infinity. Now, and you're going to tell me there's a bounded below. At y equal to 0, because there's nothing underneath, and you can tell by the domain range also. So by looking at this graph, if you memorize all the graph, you can tell me all the information you need. You can tell me this is even function. You can tell this by looking at the graph as well, because if I have a graph and if I have this line here, is a mirror, and they are mirror image to each other, and therefore if the mirror on the y-axis, then you told me that's even functions. If mirror on the diagonal line this way, then you're going to tell me is R function. You can also prove it algebraically. You can say f of minus x equal to minus x squared equal to positive of fx, because that's equal to x squared. So you say that's an even function. And you're going to tell me there's an x-intercept at 0, 0, or vertex. So in this case, there's a vertex at 0, 0, or x and y intercept in this case. So the vertex at 0, 0, that's really, really important, because later on you're going to tell me how do they shift its go from that vertex. Okay, next function is we're going to clear this, and we're going to clear this, and we're going to discard. Next function is the x cubed, which is we know as a cubic functions. The cubic function says this: x to the third is a cubic. Okay, or the way I look at it is like a waterfall, and has a breaking at 0, 0. So waterfall, and it's coming down like this, and you break here, and then go back down again. So it has a waterfall, has a break, and it's from left to right, and it's going down. And you can tell me where's domain and range on this one. Domain is, again, is all real number, and range is, again, negative infinity to positive infinity, because it has all the values. There is no bound. right? There's no bound here by looking at the graph. And you can tell me there's even or odd function. And by looking at even odd function, you can, again, is here. If it has this diagonal line, is the mirror image. Then you're gonna tell me it's odd function. By looking at the graph, it's told me it's odd functions. So it's odd functions. Where's the x-intercept? X-intercept is at 0, 0. So it's x-intercept. Or the center or origin is at 0, 0. And you say, okay, you can tell me that shift is going from there. Okay, from that x-intercept. Then let's go look at the next graph. The next graph is 1 over x, and those of you that in my class, you know that is looks like the gain sign, which is I say, and that's one of my favorite. So it looks like something like this, or the other way around, depending how your graph look like. It's this way coming down, and this way is coming down. There's a x vertical asymptote, there's a horizontal asymptote. So therefore, this domain and range is that kind of tricky. So you do need to know, and I already covered this the other day. So the domain and range is gonna be from negative infinity to 0, and unit from 0 to positive infinity. Range is going to be exact same way. Range is going to be from negative infinity to 0, unit from 0 to infinity. This one has a vertical asymptote and has a horizontal asymptote at 0. This one doesn't have a x or y intercept, so but the vertical asymptote or horizontal asymptote is at 0. So that's where the shift. There is no bound above. There's no bound here, except where the asymptote is. Okay, y is equal to 0, x equal to 0. There's a bound in the middle, but I would say that's no bound. And you're gonna tell me this is an even or odd function. Again, how do we identify even or odd function? Is draw a line here, and you see if they are mirror from each other. So draw a line here, and you say yes, they are mirror. Those two things are the same. So therefore, it's it's odd function. So it's an odd function here. So odd functions. So odd function. You can prove it by plugging negative x again. Now I'm not gonna do that from now on. So you just have to be able to analyze them from the graph. If you memorize the graph, you should know if they are odd or even functions. So it's really nice. Okay, so next thing is square root of x. And the square root of x is really like the way I always tell people, it looks kind of like a quarter of football if you just cut off right here. Okay, if you look at it here, it looks like quarter of football. And if you look at this curve, you say, okay, this one has domain is what? From 0 to infinity, and is equal to 0. And your range is what? Again, from 0 to infinity. By looking at a graph, you can tell me this already. There's a bound. there's a bounded from below. There's a bound below, and there is bounded from the domain as well. Okay, so it's a bounded below and also bounded from actually from at the left. Okay, bounded at the left, but we don't need to worry about that. Left. Okay. Your x-intercept, then this one is neither odd or even, so none of both. So it's it's neither odd or even, and you're gonna tell me the x-intercept is at 0, 0. Again, outer shift at 0, 0. Okay, outer shift is at 0, 0. So this is a very, very valuable thing to know. Is that is very, very valuable. So that's the x-intercept. And you're gonna go to the next function. You're gonna say, okay, let's look at the next function. Y equal to e to the x. And this is an awesome graph because later on you're gonna learn this. The derivative is same, and the graph is same. So e to the x is like an exponential graph, exponential functions, and they will intersect at 1. So that's something you need to know. And you're gonna tell me following things. You're gonna tell me, first of all, is f of x is equal to e to the x. You're gonna tell me domain is all real, and it's gonna be from negative infinity to positive infinity. Your range is gonna be, according to this, there's a bounded below, so it's gonna be is equal to from 0 to infinity, and there's a bounded below. And this graph you have to memorize it. Bounded below. If you memorize this graph, it's gonna make your life a lot easy when you go to calculus. It's not neither odd or even functions. Neither odd or even. By looking at the graph, you can tell. And then you're gonna tell me whether the x-intercept is or y-intercept. So y-intercept is at 0 and 0. That's where the graph is gonna shift. So it's 0, 0. So you gotta memorize this graph. This is one thing that you have to probably memorize. And if you memorize e to the x, it's best to remember to natural log of x, because the y-intercept is not 0, 0. It's 0, 1. It's 0, 1. Okay. And there's a horizontal asymptote as well. Horizontal asymptote is at y equal to 0. So there's a horizontal asymptote on this one. So you see this line, it gets so close to 0, but it's not 0. If you zoom in, we're gonna zoom in a second, and you're gonna zoom in, you're gonna see they never touch each other. So let's go to the next one. You remember this function, and we're not gonna erase this one. Okay, we're not gonna erase one because next one is gonna relate to this one. So that's discard. And so this one is if you see here, the first one, e to the x, is intersect at 0, 1, and this one is intersect at 1, 0. They are inverse to each other. Okay, they are inverse to each other. There's a mirror image here, but they are neither odd or even function. They just happen to inverse to each other. So the functions look like, if you remember one, you should be able to easy to draw another one out here. And you say, okay, what is the special about natural log of x? So you're gonna say, okay, first of all, y to the f of x, the domain is gonna be, the domain here domain is actually from 0 to infinity, because you don't see anything on the left side of the graph. The range is from negative infinity to positive infinity, and they are neither even or odd, but they are his inverse to e to the x. Okay, inverse to e to the x, and there is a vertical asymptote at x equal to 0. So there's a vertical asymptote here. Okay, and the x-intercept is at 0 and 1. 0 and 1, and that's very, very important. And you're gonna know this is a natural log of x. And let's go to the next graph, which is sine of x and cosine of x. Again, they are related to each other in some way. So I'm gonna skip that. We're gonna go to y equal to absolute value of x. Everybody know this one? Again, the domain is f of x equal to absolute value x. Domain is all real. By looking at the graph, it looks like a V shape. So this one gives you a V shape. Okay, the range is gonna be from it's gonna be 0 to infinity. Is this even or odd function? This is actually an even function, because you look at their reflection on the y-axis. And where's the vertex at? Vertex at 0, 0. And there's a bound below. Bound below here. Okay, bound below. And that's all you need to know for absolute value x. One last thing. Now the next full function is gonna be something that we haven't seen before, which is y equal to sine x or y equal to cosine x. Some of you guys have already seen it from trigonometry analysis functions, but y equal to sine x is basically like this. You have, this is f of x equal to sine of x. The domain on this one is again all real. Okay, but the range is kind of tricky. The range is, you're gonna see here, between 1 and negative 1. So your range is gonna be 1 and negative 1 to 1. Okay, your range is gonna be, so you're bounded above and bounded above and below and below. At y equal to 1 and negative 1. Okay, they are bounded one. It has an origin at 0, 0, 0, 0 as x-intercept and y-intercept, because you're looking at this graph. And it actually looks like a wave. It starts at 0. So sine of x is a wave, start at 0. Wave, start at 0. And that's the start at 0. Okay, it go up. See here? It goes up and come back down. Okay, but the cosine x is done differently. So always remember, sine of x is sine start at 0. Okay, sine start at 0. Now let's look at next, cosine of x. And this one's kind of tricky. This one is actually, it doesn't start at 0, but it starts at 1. So it starts at 1. So this one's cosine of x, this one is sine of x. See how they're different from each other? Cosine of x, sine of x. Cosine of x, sine of x. So cosine of x actually starts at 1. So y equal to cosine of x, y equal to cosine of x. It starts at 1. Okay, wave start at 1. At 1. And I forgot to mention, sine of x is actually a R function. So we're gonna rewrite that again. So again, domain is gonna be negative infinity to infinity. Your range is gonna be from negative infinity to no, not negative infinity, negative 1 to 1. So there's a bounded below and above. At 1 and negative 1. And this one is actually an even function. I forgot to mention last one, the sine of x is actually R functions. And this is very important, even function and sine function. The origin, the y-intercept is at 0 and 1. So that's a y-intercept. And that's all you need to know for this one, cosine of x. You need to know that, cosine and sine is come in pair. Natural log and e to the x come in pair. It's best to memorize them both at the same time. Now the last one, the last two I never bothered to remember, honestly. I don't think it's very important, but you do need to know it. It's called, this one, I don't know what it's called. It's called the logistic functions, and it looks like this. And logistics functions are 1. F of x is equal to 1 over 1 plus e to the minus x. Do you need to memorize it for me? I'm not very care about that much. You probably get tested. Just tell me how to graph this. Then you say, okay, this graph basically is intersect at 0.5, and is domain and range in here? Yes, there's a domain. It's going to be negative infinity to infinity. Your range is going to be from 0 to 1. Okay, 0 to 1. Never equal to 1, never equal to 0. And is R even function? Is neither odd or even. And is it discontinuity somewhere? No. Is intercept, y-intercept is at 0 and half. Is it bounded? Yes, is it bounded? Below and above at y equal to 1 and 0. If you see the graph is bounded at 1 and 0. And that's all you need to know. Why do you need to know this one? There's a 2 horizontal asymptote also. The horizontal asymptote is right here. That's why they are bounded. Anything else? Oh, greatest integer functions. The greatest integer function looks like this. And it's not the one I can graph. So I'm going to graph here. It's gonna be like this. I'm gonna graph this function very fast. It's gonna be here to open circle here, and here open circle to 2, and from here it's gonna be open circle to all the way, close circle to open circle to 3, and this is called the step functions. And it looks really, really funny, but basically look like this. Do you know how to graph? Do you need to know how to graph this one? Yes, you do. The domain and range all have to be integers. All integers. So it's called the greatest integer functions. So f of x, this one is called greatest integer function. Greatest integer function. Greatest integer functions. And basically it just, if the x value is -1, it's gonna go all the way up there, and you're gonna get 0 here, and then you're gonna go from x value is 0, then all the way up here is always 0 until the next point is equal to 1. And they also call it a step function. It looks like a step, like a doodle jump. Okay, jump from here, here, here. It always have a closed circle on the left end and open circle on the right end. This one, there's not a lot of shift on this one. You don't have to know anything except look at this graph, and you gotta be able to tell me this graph is it. Okay, so that's a 12 basic function graph, and later on, if you had to memorize all this graph, you have to know everything detail about them. Best know is remember all the graph look like. You can get everything else information from the graph. Okay, you can gain from every graph. So if you memorize all the graph, then you don't need to worry about it. All the information is inside the graph. Domain, range, even function, bounded below, bounded above. Where's the vertex, where's the x-intercept, y-intercept, it's all over there. Okay, so that's it for this.